Can lightning strike an aircraft? Last week, a passenger aircraft was reportedly struck by lightning. But here's the mystery. An aircraft isn't connected to the Earth. So how can lightning possibly strike it? And if it does, why doesn't the aircraft fall out of the sky? The answer is far more surprising than you might think. You might think a lightning strike on an aircraft is extremely rare. In reality, a typical commercial airliner is struck by lightning about once every year. But here's the real surprise. Aircraft are actually designed with the expectation that lightning will strike them. To understand why, we first need to understand how lightning forms. Inside storm clouds, powerful air currents separate electric charges. Some regions become positively charged, while others become negatively charged. As these charges build up, the electric field becomes stronger and stronger. Eventually, nature finds a way to equalize the imbalance. That's when lightning occurs. Many people imagine lightning only travels from cloud to ground. But that's not true. Lightning simply seeks a path between regions of opposite charge. The ground is not the only possible destination. Under the right conditions, a flying aircraft can attract a lightning discharge just as the Earth does in a cloud-to-ground strike. In some cases, lightning doesn't simply strike an aircraft. The aircraft itself helps create the lightning channel. As an aircraft moves through a highly charged region of the atmosphere, it can disturb the local electric field and trigger a discharge. The lightning may attach to the aircraft's nose, wingtip, or tail. The electrical current then travels along the outer surface of the aircraft before leaving from another point. But aircraft weren't always this well protected. In fact, lightning has brought down aircraft in the past. One of the most famous cases occurred in 1963, when a lightning strike ignited fuel vapors inside a fuel tank of a commercial jet. The resulting explosion tore the aircraft apart in midair, killing everyone on board. So how could a single lightning strike lead to total destruction in seconds? It wasn't the lightning alone. It was a deadly chain reaction. The lessons were learned, and measures were taken to prevent such tragedies from occurring again. Those hard-learned lessons helped make modern aircraft far safer. Today, commercial airliners are struck by lightning regularly. Yet catastrophic accidents caused directly by lightning have become extraordinarily rare. But why doesn't a modern aircraft burst into flames? The answer lies in clever engineering. Most commercial aircraft are surrounded by a conductive outer skin. This creates what scientists call a Faraday cage. A Faraday cage directs electrical current around the outside, rather than through the interior. As a result, passengers and onboard systems remain protected. Engineers also install special bonding straps, conductive paths, and lightning protection systems throughout the aircraft. Critical electronics are carefully shielded against powerful electromagnetic effects. Before entering service, aircraft undergo extensive lightning testing. Engineers deliberately expose aircraft components to massive electrical currents that simulate real lightning strikes. Only after passing these tests are aircraft certified to fly. That's why pilots usually continue flying normally after a lightning strike. In most cases, passengers may see a bright flash and hear a loud bang. But the aircraft remains perfectly safe. So the next time you see lightning outside an airplane window, remember this. The amazing fact isn't that aircraft get struck by lightning. It's that engineers design them expecting it. And thanks to decades of science and engineering, one of nature's most powerful forces has become just another challenge that modern aircraft are built to handle. Did anything in this video surprise you? Let us know in the comments below. And if you'd like more fascinating science explained in simple terms, don't forget to like, share and subscribe to Science Unlocked. Until next time, stay curious.